Hello children, let us start with the lecture number 9 of current electricity, right? Okay, what do we have here in this lecture? In this lecture, we are going to do the numerical questions. Okay, so it is type D. And what are the formulas we are going to work on today? And it is W is equal to I square RT. अरे भाई करंट जब पास होता है ना वायर के अंदर से, हाँ, तो इस वायर के अंदर हीट प्रोड्यूस होती है. एंड हीट क्या है? एनर्जी. एंड एनर्जी क्या है? वर्क डन, राइट? एंड दिस वर्क डन वी हैव द वर्क डन इज इक्वल टू आई स्क्वायर आर टी. ठीक है, हमने लिख लिया फॉर्मूला. अब दूसरा जो फॉर्मूला होता है ना बेटा, मुझे पता है कि एक और फॉर्मूला होता है हीट का, एंड हीट इज इक्वल टू वी स्क्वायर इंटू टी डिवाइडेड बाई आर, एंड डब्ल्यू इज ऑल्सो इक्वल टू वी इंटू आई इंटू टी. वॉट इज वी? वोल्टेज. आई इज द करंट एंड टी इज द टाइम. देखो मेन ये वाला जो फॉर्मूला होता है दैट इज आई स्क्वायर आर टी होता है, और उससे निकले बाकी दोनों फॉर्मूलाज होता है. ठीक है, लेकिन डिपेंडिंग अपॉन द क्वेश्चन वी हैव टू अप्लाई द राइट काइंड ऑफ द फॉर्मूला एंड डू द क्वेश्चंस. ओके, और क्या फॉर्मूलाज होता है बेटा? पावर का अपन को पता है कि वर्क डन डिवाइडेड बाय टाइम, एंड यू नो दैट the formula for the power is I square RT divided by T, and T will cancel out and we will be left with I square R. Another formula is P is equal to V square divided by R, and also power is equal to V into I if it is in what? If all the measurements are done in the SI units. Okay, ठीक है, तो let us do the first question. Now what we have is 100 joule of heat is produced each second in a 4 ohms resistance. Find the potential difference across the resistors. Okay, what is given? Heat. How much? 100 joule per second. So if it is then not heat, but this is the power, because energy per second is equal to power होता है ना? And what is the resistance? The resistance is given as 4 ohms. What is the formula? We know that the power is equal to P, and P is equal to V square by R, and you are supposed to find out the potential difference, and potential difference is V. We know the value of the power, which is equal to 100, and voltage nikalna hai, resistance is equal to 4. So what is the value? It is V square is equal to 400, and V is equal to under root of 400, which is equal to 20 volts. Okay, therefore the potential difference is equal to 20 volts, and this is our answer. Done, the first numerical. Okay, so let's move on to the second question. Here comes the second question. Compute the heat generated while transferring 96,000 coulomb of charge in 1 hour through a potential difference of 50 volts. अब भाई क्या करना है? We have to find out the heat when 96,000 coulombs of charge is transferred in 1 hour through a potential difference of 50 volts. What's given? Given is potential difference is 50 volts. Time is 1 hour. We can write it as 60 into 60 seconds. Huh? Charge is equal to 96,000 coulombs. And here you are supposed to find out the heat. How to find out the heat? Now we know that heat is equal to V I into T. बेटा यहाँ तो आप देख रहे हो कि हमारे पास में वोल्टेज है, करंट नहीं पता, लेकिन टाइम है. तो सबसे पहला काम क्या होगा? वी हैव टू फाइंड आउट द करंट. सो करंट इज इक्वल टू, आई नो इट इज इक्वल टू चार्ज डिवाइडेड बाय टाइम. सो व्हाट इज द चार्ज? इट इज 96,000 by 3,600. So cancel it off, and you will be getting the answer as 80 by 3 amperes on calculations. अब अगला काम क्या? All that we have to do is to substitute the values out here. It's 50 into 80 divided by 3 multiplied by 3600. Cancel this off. That is 1200. So this is equal to 4.8 into 10 to the power of 6 joules. So, the heat which is generated is equal to 4.8 into 10 to the power of 6, that much of joules. Okay, and this is your answer. Right, let's move on and do the question number 3. Okay, now let's move on to the next question. The question number 3 क्या कहता है भैया? It says that an electric iron of resistance 20 ohms take a current of 5 amperes. Calculate the potential difference in the heat developed in how many seconds? It is the 30 seconds. So what's given to you? You are given the current. Current is 5 amperes. Okay. And what about the resistance and time? The time given is 30 seconds and the resistance R is equal to 20 ohms. Okay. So next, what are we supposed to find out? To find क्या करना है हमें? To find is the finding out the heat. कितनी heat produce हो रही है? So what is the formula? The formula used, it is equal to H, which is equal to I square R into T. All that you have to do is to substitute the formula and get the answer. So it's 5 into 5, I ka square, R is 20 and time is 30. So what's the answer? 25 into 60. So it is 1500, that much of joules. That's it, right? So the heat produces 15,000 joules. Okay, a large amount of heat is produced. Hey, what does this fourth question says? It says that an electrical iron consumes an energy at the rate of 840 watts when heating at a maximum rate and 360 watt when it is heating at the minimum. The voltage here is 220 volts. What is the current in each case? Okay, when the power differs now, the iron is using different resistances. आपने देखा होगा ना, in the electrical iron you have got a knob here. This knob is actually adjusting the heat or adjusting the power, right? When you want to heat something like a cotton one or a linen one, you will use high power, and if it is cloth like silk or maybe any other things, you will be using the low power. What exactly you are doing is, while using the low power, you are using the resistance which is different from the one which you are using in the high power. So we have got an electrical iron out here, and this is connected to the supply. Now in the supply you can see that it is current. You are supposed to find out what is the current in each case, right? So that is measured by using an ampere. Again, here we are not using a DC. Here it should be actually an AC current. Okay, anyway, the diagram is like this. So I am passing the current. This current is switched on and I am getting the maximum power. What is the relation between power, current and the voltage? What is fixed here? The voltage here is fixed. And what is the voltage? It is 220 volts. What is different? The resistance is different, and so the current is different, and so is the power which is different. So we all know that in the case of the first one, the maximum power. Now, what is the power which is maximum? So, the maximum power what we have here, it is equal to 840 volts. Now, the voltage I know it is equal to 220 volts, that is fixed. And if I talk about the current, let me call this current in the case 1 as I1, and the power is P1, and voltage it is equal to V. The relation, the formula what we have got, power का बोलो क्या होता है? Power is equal to voltage multiplied by the current. Okay, voltage is V, current is I. So power is P1, so current is I1 here. So the power is given as 840, voltage is 220. So I'm supposed to calculate the current in the first case. Okay, so what is that? I1 is equal to 840 divided by 220. Cancel this off. To say you will get 42 divided by 11, that much of amperes. Okay. Now what about that in the case 2? In the case 2, we know the minimum power, and that is equal to P2, which is given as what? It is given as 360 watts. Okay. Now what is the voltage in this case? The voltage is not changing. Voltage is equal to V, and that is 220 volts. Now what is the current in this case? It will change. So current here, let me say that it is equal to I2, and that is what I am supposed to calculate. So P2, that is equal to V multiplied by I2. What is P2? It's 360, voltage is 220, and supposed to calculate, multiply kar lo, and you will get I2. What is I2, bacha? I2 is equal to 360 divided by 220. Then cancel it off. This becomes 18 divided by 11. So what's the answer? It is 18 divided by 11 amperes. The current in both the cases is different. राइट जब हमारे पास में पावर ज़्यादा यूज़ हो रहा है तो करंट भी हमें ज़्यादा मिल रहा है, एंड जब हमने पावर कम यूज़ किया 360 कंपैरेटिवली कम है, सो इट इज़ लेस, दैट इज़ 18 डिवाइडेड बाय 11 एम्पियर. सो होप दिस इज क्लियर. ओके, लेट्स मूव ऑन टू द नेक्स्ट क्वेश्चन. ओके बच्चों, let's move on to the fifth question now. In this question, he says that an electrical bulb is rated at 220 volts and 100 watt. When it is operated at 110 volts, what will be the power consumed? Bulb remains the same. So we have got a bulb connected to the supply, and the supply, the voltage is 220 volts initially in the case 1, and then the current is, I don't know the current, and now I'm changing it to 110 volts. What will happen to the power consumed? Initially the power was 100 watt. Will the power be the same, or the power is different? Now what is the key point here? Now the key point to understand here, the resistance will remain the same as bulb is same. Bulb नहीं change हो रहा, so the resistance is also not changing. That is the main idea. So what will I do here? I know the voltage, I know the power. Can I calculate the resistance? Yes. And in the next case, the voltage is changing, but the resistance remains the same. All I have to do is I have to calculate the power. Okay. Now, what is the case 1? Here he says voltage is 220 volts. What about the power? The power, we are given that it is equal to 100 watts. What's the relation between power and voltage? So power, we know that is equal to V square divided by R, because we are given the voltage and we have to find out the resistance. The power here is 100 and the voltage is 220 into 220 divided by R, or we can write the resistance here is 220 into 220 divided by 100. So 0 and 0 will cancel. 22 into 22, it is 484, that much of ohms. Now this is a constant, right? Please remember that this value is going to remain a constant, right? Now, so we are now next going to find out the case 2. In case 2, what is happening? In case 2, the voltage is changed. We'll say that it is equal to V2 and that is 110 volts. But what about the resistance? Now in the resistance, we know that it is going to be remaining a constant. This is the value I am going to put there. Okay, now so how do I do it? Resistance is equal to and which is equal to 484 ohms. Now what is the relation between power and voltage? We know that in this case this is power 2 and that is equal to V2 ka square divided by R. Now power V2 I know that is how much? 110 into 110 divided by 484, or I can write this as 110 into 110 multiplied by 22 into 22, 484 को लिख सकते हैं. So we can cancel out with 11. So this becomes 10 times and this also becomes 10 times, and here I am left with 2 and 2. So this will cancel out 5 times and this is also 5 times. So total it is equal to 25 watts. Okay. Now in the first case the power consumed was 100 watts when the voltage dropped from 220 to 110. The power dropped to 1/4 of its value, and here in this case you can see that it is only 25 watts. And this is the key point. What? Agar bulb nahi change hota hai na, if the bulb is not changing, what is not changing? It is the resistance which is remaining the constant. So keep it in mind. Okay, so let us move on to the next question now. Right? Okay. Next question is rather very easy. Electric bulb is connected to a 220 volt generator. Current is 0.5 amperes. What is the power of the bulb? Okay, the power of the bulb. So voltage is given beta. How much is it? 220. What is the current which is given here? It's 0.5 amperes. All that you have to do is to calculate the power of the bulb. Very, very simple. So what is given? First write that. So given is the voltage. How much? The 220 volts. What about the current? The current is 0.50 amperes. Put this as V, put this as I. What is the formula? Now we all know power is equal to voltage multiplied by current. Okay, so what is the voltage? It is 220. 0.5 इसका मतलब हम half लिख सकते हैं. So cancel this. This is equal to 110 watts. बस the power is calculated and you know the answer now, right? Okay, highlighted. डब्बा बना दो. Yes, this is the answer. Very simple question. Done and dusted. ठीक है. Seventh question is again very, very simple question. What is given to you? You are given that we have got a electrical heater. Resistance is 8 ohms and draws 15 amperes of the current from the service mains for how many hours? It's 2 hours. Calculate the rate at which the heat is produced. So first thing you will do is you will write what is given to you. बेटा बच्चा क्या क्या दिया है? You know the resistance. What is the resistance? It is equal to 8 ohms. What about the current? The current is given as 15 amperes and put it as I, and this is R, and you are also supposed to find out the power when the time is power nahi heat produce करना है. Time is 2 hours. Okay, 2 hours means 2 into 3600 seconds. Now what is the formula for the heat? Bolo, bolo, bolo. I square R multiplied by T. So what is the value of I? Beta, it is 15. So 15 into 15. What is the resistance? I know it is equal to 8 ohms. And what about the time? It is 2 into 3600. Beta, multiply and get the answer. Very easy. Come on. 225 into 16 into 3600, that much of joules. Calculation part कर लोगे? मुझे करना पड़ेगा. हाँ, करके तो लिखो. Come on. आंसर कितना आया? 1, 2, 9, 6 और 0, 0, 0, 0. That much of joules. अरे बाप रे, इतना सारा पावर कंज्यूम हो गया आपके पास में. हाँ, तो हीटर में बहुत ज़्यादा लगता है ना पावर. तो हीटर को सोच समझ के यूज़ करना चाहिए. राइट? ओके, लेट्स मूव ऑन टू द नेक्स्ट क्वेश्चन. The next question says, there are 2 lamps One rated at 100 watts, 220 volts, another at 60 and 220 volts are connected in parallel to the electric main supply. What current is drawn from the line if the supply voltage is 220? So what is given to you? दो bulb दिया हुआ है, देखो. There are two bulbs. The first bulb has got a power of 100 watt and the second one has got a power of 60 watts. How are they connected? They are connected in parallel. Parallel means this is the way how it is connected. So what will happen to the total current? Okay, now let us talk about the voltage. What is the voltage through the supply? It is given as DC, but actually this is a AC supply. Okay, now the घर पे तो AC ही होता है ना. So the power is also given to you and you are supposed to find out the current. How to find out the current? Let the total current be equal to say I. Now I know that when the supply is given to these two bulbs and they are connected in parallel, the current here will be equal to I1 and the current here that is equal to I2. Okay. Now we all know that the bulbs when they are connected in the parallel, so the voltage remains the same. Now if I talk about the voltage at the point A and B and the voltage at the point, if I call this at C and D, they are actually the same. So the voltage across the points AB will be equal to the voltage across the point CD and that is equal to 220 volts. Okay, that is the supply. जो supply होगा उतना ही होगा इसका. Now, what about the current? The current will be different in both the cases. Okay. Now, we know for the bulb 1. What is the power 1? We know power is equal to voltage multiplied by the current in the 1. So, current I1 is equal to P1 divided by V. What is the value of P1? It is 100 and the voltage is 220 volts. Okay, if you cancel this, it becomes 5 by 11, that much of amperes. And what about for the bulb 2? This is the bulb 2, right? So, what is the power? The power 2, it is equal to voltage multiplied by the current in the bulb. Okay, so what is the power? The power here, it is equal to 60 watts and voltage is equal to, I know it is 220 multiplied by I2. So what is I2? I2 is equal to 60 divided by 220. Cancel the zeros and also 2. So it is 3 divided by 11. Right, that much of amperes. But what about the total current? The total current is equal to I1 plus I2, which is equal to 5 by 11 plus 3 by 11. So that is equal to 8 by 11 amperes and this is your answer. Clear? Right. So, इसका मतलब क्या हुआ? When the things are connected, when the two electrical equipments are connected in parallel, what remains same? Voltage remains the same. But what about the power? The power may be different. So, the current is also different. But when they come out and when the join here, I1 comes and gets connected at the point here and I2 also comes here, both of them together will go in the main circuit. So in the main circuit, what you have to do is you have to add up both the current, right? समझ गया ना? लिखो 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 जल्दी लिखो. Good boys and good girls. Okay. The last question of this video, 10th question. Two conducting wires of the same material and of equal length and equal diameters are first connected in series and then connected in parallel. Now, across the same potential difference, the ratio of the heat produced when they are connected in series and then connected in parallel, the combinations would be, what is the amount? See, what are you supposed to find out? I've got two wires. They are of the same material, same length, equal diameters. First, they both are connected in series, right? So we will say the case 1. So in the case 1, we can see that, just one second, I'll take another pen, I'll take the white pen. Now I have got these two resistances, and the resistance, if I take it, it is R and R, and they are connected to a supply, the voltage here, that is equal to V. And in the case 2, what they are doing is, both these resistances are connected in parallel, and again the supply remains the same, so the voltage here, it is same. So if you have got the two materials of equal length, equal diameters and everything, the resistance also will remain the same. So what is the heat produced in the first case? Bolo, heat produced in the first case, let me call this as H1. I know that is equal to V square by R multiplied by G. Right. So voltage is the same. And what about the resistance? In this case, both the resistance are connected in series. So what about the resistance in series? That is equal to R plus R, which is equal to 2R. So what is the heat produced? I know it is equal to V square. Time is also the same, and the resistance becomes 2R. Right. Mark this as equation number 1. What about the case 2? I want the resistance to be in the parallel. So what is the equivalent resistance? We all know 1 upon Rp is equal to 1 upon R plus 1 upon R, that is equal to 2 upon R. So what about Rp? Rp is equal to R by 2. So what is the heat which is produced in the second case? Call this as H2. What's the formula? V square into T divided by Rp. So V square remains the same, time remains the same, and this becomes R by 2. So you have to mark this as equation number 2. What is they asking for? They are asking for the ratio of the heat produced. So you are supposed to find out H1 by H2. So it is V square T divided by 2R divided by V square T divided by R by 2. So this becomes V square T divided by 2R multiplied by R by 2 multiplied by V square into T. See, V square cancel, T cancel, R cancel. So what is the value? 1:4. So what is the answer? The heat which is produced in the series is to heat which is produced in the parallel. In both the cases, it is in the ratio of 1:4. So which is the correct answer? C is the correct answer. Right. So note this. क्वेश्चंस अलग और आंसर्स अलग, बन तो जाना चाहिए, लेकिन जब भी मेरे सोल्यूशन देखोगे ना, उसके पहले एक बार खुद से ट्राई जरूर कर लेना. Right? Hope everything is clear. Any doubt, please ask me. Okay. Thank you for attending the classes. And now you have to share this with your friend. And don't forget to complete your notes. And also read the book and do as much as questions you can do on your own. Thank you, bachcho.